students, I hope you're doing well today. So I'm sorry for not having live Zoom calls, but I had to set up the egg experiment, and even though it's quite simple, it does take some time with taking off the shell from the egg, measuring out things carefully. So I'm going to show you how I set up the egg experiment, how I took all the measurements, and then tomorrow I'll show you the results, hopefully live. I may have to film that, but we will have a live Zoom class. So please pay attention to the next couple steps where I'll go over how I prepared the eggs, how I made the solutions, how I measured the eggs and the solutions, and then where I stored it. So the brown eggs have been soaking in vinegar for about 48 hours, and you can see over here that brown, gooey, icky stuff is actually the pigment that's come off. And now I'll rub off any of the remaining eggshell that you can see. Your fingers are the best tool to use for this because they're quite light, but if you don't feel comfortable using that, you can use an old toothbrush. So pretty much I stored the eggs in this old Cool Whip container, and I'm not going to show you the actual process of me rubbing off the eggshell. What helps is if you have running water and you do it for a while, you can also redip it in some vinegar. Basically, of the 6 eggs that we originally started off with, all we ended up with were about 5 eggs. Unfortunately, the 6th egg had a little hole in it. So why do eggshells dissolve in vinegar? They are made mainly of calcium carbonate, which is the same substance chalk is made out of. Vinegar found in the grocery store has 5% acetic acid. The formula for acetic acid is CH3COOH. Acetic acid is a weak acid. I show the positive and negative charges of acetic acid on the tops of the molecules. Positive and negative charges show how many electrons those molecules need or have more of. In the solution, the vinegar dissociates into the positively charged hydrogen ion and the negatively charged acetate ion. We are going to focus on the hydrogen ions for right now. The hydrogen ions protonate or bond with the carbonate ion from calcium carbonate in order to form another weak acid known as carbonic acid. Note that 2 hydrogen ions join to balance the 2 negative charges on the carbonate ion. Then the negatively charged acetate joins the calcium ions to form calcium acetate. Let us go back to the carbonic acid we previously formed. It is now going to dissociate into water and carbon dioxide bubbles. Any bubbles you see forming are filled with carbon dioxide. Due to these reactions, the shell dissolves, leaving behind the outer and inner membranes. Most students have a misconception that there's only one membrane that's left after the shell is dissolved. These 2 membranes allow for substances to move in and out of the egg cell. In this experiment, our goal is to see what happens to the mass and length of the naked eggs as we put them into different concentrations of sugar water, which is made from distilled water and corn syrup. You will want to use a food scale if you have access to one to get the mass. I'm also going to make the sugar solutions using corn syrup. You could use brown sugar if you would like, but I find corn syrup is easier to actually dissolve finally. And then you are going to use distilled water, which is basically water that has no ions or particles you'd find in spring water. It's not drinkable, however. I'm going to show you my calculations for the amount of water and corn syrup that you are going to need to use. So when you don't have access to a graduated cylinder, an important fact to remember about measuring out water is that 1 gram of water is equivalent to 1 milliliter of water, which is a standard unit for creating solutions in science. It's also important to remember that 1 milliliter of corn syrup is also equal to 1 gram of water. This is typically what people do with glucose solutions, which is the technical way of doing it, but in our kitchen science, corn syrup is the closest that people are going to get to glucose solutions. So for example, if you're making a 10% sugar solution, you're not going to use 100 mils of water and then put 10 mils of the sugar solution. You're going to use about 90 mils of your water, and then you're going to put 10 mils of glucose because they're the same, so you get 100 milliliters of your solution. So in the 0% solution, you are using pure distilled water. You're not adding any corn syrup to it. In the 5% solution, you're adding 95 milliliters of distilled water and 5 milliliters of corn syrup. In the 10% solution, you're adding 90 mils of distilled water and 10 milliliters of corn syrup. In the 12% solution, you are using 88 mils of water and 12 milliliters of corn syrup. And finally, in the 22% solution, you are putting 78 milliliters of water and 22 milliliters of corn syrup. And because the grams are equivalent, I'm going to just swap out all of these milliliters with grams. You will then want containers of the same size. I would suggest using a cup-like vessel. I am using mason jars, but plastic cups work just as well. The 5th cup is a plastic cup because I didn't have another mason jar, but it had a similar size. Sorry for breaking my own suggestion. Then you are going to want to put some water into a measuring cup, just like I'm doing right there. Next, you should label the concentrations on the mason jar. I'm using Scotch tape and Sharpies. We are going to measure the mass of the water for each of the solutions first, and the easiest way to do this is to actually just tare the empty container. You might know about this from middle school and high school, that whenever you're taking the mass of something, you always first take the mass of the empty container, put whatever you have into the container, and then subtract the mass of the container. Tearing is easier. All you do is take the empty container and you hit the tare button, which is going to be right underneath my finger on the right. So once you press the tare button, then you're just going to wait for the screen to go to 0, and all you have to worry about at that point is just the mass of whatever you're putting into the container. Here I'm just adding water into the different containers and measuring them according to that list of measurements I posted earlier in the video. Here I am measuring the corn syrup into this metal bowl, and I'm using a plastic spoon because it's easier to clean up. You do have to be careful with measuring in the corn syrup because it's more viscous than water, so you can easily add quite a bit of it without being able to stop it. Next, I am mixing in the corn syrup, so you can see that there's still dense ribbons of it in the solution, and I like to mix it onto the scale so that I'm able to get to that 100 milliliters after adding in the sugar. You also do want to be careful when you're scraping it out of the little bowl. So you keep mixing it until you can no longer see those little ribbons of the corn syrup in the solution. Next, I'm going to be taking the mass of the eggs, and it's really important that you note the mass before putting it into the containers because the eggs have a range of masses. Then I am going to measure the egg using the tape measure off to the side, and I'll be converting that into centimeters, which is a better unit to use. Once you have put the eggs into the containers, it's a good idea to seal it off with some saran wrap to prevent any loss of water through evaporation. These are the masses for the eggs along with the lengths as well. So for 0%, it is 80 grams. For 5%, it's 84 grams. For 10%, it's 72 grams. And for 12%, it is 88 grams. Finally, for 22%, it is 71 grams. Now their lengths. For 0%, 5.40 centimeters. For 5%, 6.99, almost 7 centimeters. For 10%, 6.07 centimeters. For 12%, 6.20 centimeters. And finally, for 22%, 5.72 centimeters. You should store your containers in a place that is cool and dark, like the shelf of a garage.